minutes.
Super secret base. Super secret base.
The thing, there was no homework for the weekend. It was mostly just formula and, to be perfectly honest, killing time so that we didn't have to go to section 3.2. Because I didn't want to start logs before the test. So.
We did you're not bi-weekly.
Okay.
Is it the same as semi-annually? Bi-annually would just be every.
So if you know what bi-weekly is, transfer that knowledge to, instead of week, annual. Shh.
No.
Shush.
Look it up.
Shush.
Wait, dang, just now. There's no continuous word in there. But there is. Where? This is compounding. Oh, continue. Oh, yeah. I just know that because my bi-weekly contacts normally go with bi-monthly. Can you use our resources and look it up? I am using my resources. I just need to make sure that I know crazy.
I mean, I'm pretty sure that's just called the Grand Cayman Islands, but whatever.
Oh, I knew it.
No, Riley either. Is Riley in choir? No? Yeah, there's some sort of competition. That's where Rachel is. Okay. Now, this was all calculator mojo. Please write down what you're putting in the calculator. Okay, not just the amounts, but what you are putting in the calculator. Because that's kind of what really matters. I assume that you can press buttons. Well, I suppose ritual here. Shoop, 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 and shoop. Are we there? A little bit. Also remember that after this test, you shouldn't have any need for the immediate future for your Chapter 2 packet. You can turn that in as well. Wake up, Frank. Okay, two formulas we're looking at. Amount is principal by 1 plus rate over number of times compounded to the number of times compounded by time. Or, if you hear the magic word, PERT. Okay, all depends on which of those you have. This should just be formula plug and chug. Again, I would like you to write down what it was, not just the answer. So, contestant 1, biannually. We said bi-weekly was every 2 weeks. Well, that's easy enough to do within a year, because if it's within a year, then I just take the number of weeks and divide it by 2. But if I say it's biannually, how often does it happen? Every 2 years. So when I'm doing an annual formula, how many times per year does it happen? Half a time. So I'm going to have my principal of 2 grand by 1 plus 1/2 or 0.5. My rate, 5% interest, is 0.05. So you could just divide that out and call it, 1/10, but whatever. Happening 0.5 times for 18 years. And I press the buttons. Quarterly, green, would be 2 grand by 1 plus, still going to have 0.05, still going to have 18. But if it's happening quarterly, how many times per year? 4. And if we hear the magic word continuously, we're going to switch over to continuous growth or decay, 2 grand by e to the 0.05 by 18. So, tell me about those numbers. First one. 4,000? 715? 0.9. Well, it is money. Like if you go for lunch at McDonald's and they say, okay, that'll be $5.8? No, they say it's $5.80. Okay. It's not going to change too much for both of these. If I go quarterly, be a little bit more. Okay, confirm. Seeing bobbleheads around the room, cool. And bink. If we go continuously, bobbles? Cool. So what I'm really looking for is you got the correct formula set up for them. You got the correct formula set up. Assuming you had the correct formula set up, I'm going to words. Say all of those are just within the same bracket. You got the right, you can press buttons. And then you have the correct formula set up, but something really, really lame. Like you had the correct setup, but you put 5 instead of 0.05 because you forgot that you had to change your decimal. Or maybe you said 2 for biannually instead of half. Like you had the setup, you were there, you were ready to roll, but oops. Okay, so one for each formula, one for the whoopsie in the formula, one for the answers if you press the buttons for the formula. And that's really what Friday boiled down to. We're just kind of trying to use up a little bit of time to not go through stuff. Also, maybe scare you into some responsible action as a young, nearly able to vote demographic. Everyone's got their review ready to roll. The formula stuff from Friday is not on here. So for those of you that were, that's another reason why I was kind of dirtling after I heard that there was going to be track kids gone. I was kind of worried that I was going to have half the class gone. So I wanted to kind of drag the feet a little bit on Friday. So everyone should be able to go through their test. We spent a boatload of time on rational functions. The key to it is, if you remember, you're going to have ax to the n math plus c, bx to the m math plus d. Y'all got that thing written out? Remember where the where the different features of this thing are? We're going to have zeros of the numerator do what? X-intercepts. Zeros of the denominator do what? I heard it oh so quietly. Vertical asymptotes. If I plug in 0, all this stuff with x's disappears, and the function of 0 gets me my y-intercept at c over d. Keep in mind that if numerator or denominator all have x as a common factor, that means c or d might end up being 0, in which case you would have a y-intercept of 0 or no possible y-intercept. That happens. Sometimes we get weirdo graphs. Oh, no, green, there we go. And then, a lot like the a value in a transformation does a lot of stuff, so do the leading coefficients in a rational function. If n is less than m, degree on the numerator is less. What kind of asymptote we got? Horizontal at 0. Ha! Y equals 0. Because when I try to divide something like x squared by x cubed, it goes in there 0 times. If n is equal to m, what we got? Because if I take something like 2x squared divided by 3x squared, I get 2/3. So we'll have a ha at y equals a over b. And if n is greater than m, thus far, we have not had anything more than it is greater by 1 degree. Because all of the oblique asymptotes so far that we've gotten are lines. Just know that if it's like a cubic over linear, you can have a quadratic asymptote. No, that's not on your test. I'm just saying it exists. Okay, we're going to divide to get an oblique asymptote, and we have to ignore the remainder. Do you remember why we have to ignore the remainder? There's always going to be one. What if there wasn't? That means not a 0. Numerator divided by denominator, no remainder means it's a factor. If it's a factor, that means it can cancel, and if it cancels, there's a hole. Okay. So this was kind of the holy grail of rational functions. We spent a few days on it. And here are 3 different types. No. First thing that I always do is factor, factor, friggin' factor. It's a difference of squares. Just because 3 isn't a perfect square doesn't mean you can't do it. That's x plus root of 3, x minus root of 3. And the reason I write it like that is because now my numerator tells me my x-intercepts. So I'll have x-intercept at plus or minus root of 3, which is, has anyone got that ballpark decimal memorized the same way that we memorized 1/3 and 2/3 back in elementary, middle school? Okay. About 1.73, just like square root of 2 is about 1.41. Okay, and those are just decimals that we should be familiar with because they happen often enough. So we've got x-intercepts, thar and thar. What else can I do? Vertical asymptote at -1. Okay, don't just put the features over here. Also tell me that. Vertical asymptote x equals -1. That way I know what it is, why you're doing that. You're not just winging it off a graph. You're not just guessing. Like, you actually know how these are created. Tell me the x-intercepts are plus or minus root of 3. Okay, what else can we find? Y-intercept. The function of 0 is -3, which is my y-intercept. Yint. Make a dot. And then I go and look at my leading terms and their degrees. The degree of the numerator is greater, so I have to what? Divide. Be oh so careful. When you divide, you have the choice of long or synthetic division. Most of us are probably going to go synthetic because I'm dividing by a linear factor. What do I got to be careful about here? 1, 0, -3. I need my placeholder. Drop the first one like it's hot and get started. -1 by 1 is -1. Add them together. -1 by -1 is 1. Add them together. I'll get a remainder. It doesn't matter. What does this do for me? Okay, y equals mx plus b, right? We get our oblique asymptote at y equals x minus 1. So, starting at -1 with a slope of 1. And if I have those couple of dots there and those 2 asymptotes, do you have enough to finish off the graph? You see how tight, close into the asymptotes they are? So that tells me that I can just curl along the asymptotes and call it good. Because when I check these, that's the information that I'm looking for, the same as I did on daily checks. I want to see if you got your intercepts, your asymptote, your asymptote, your intercept, and then I'm going to check to make sure your graph is reasonable. Okay? 5 points. So, there are 3 rational graphs on the front. No guarantee what kind will be where. But I'll tell you that you will probably have an oblique asymptote on one of them. You will probably have a hole on one of them. You will probably have a multiple vertical asymptote on one of them. Because those are the things that are kind of newer once you get to Algebra 2 and beyond. So, this guy. Factor, factor, friggin' factor. Numerator is difference of squares. I'll call it x plus 2, x minus 2. Denominator, take out x as a common factor. Factors of 6 add up to negative 5. Or is it positive 6, negative 1? Or negative 6, positive 1? I'm just wondering, like 6 messes with kids. I took an x out. Yeah. You're right, it is negative 2 and negative 3. It's just 6 messes with kids. 6 messes with kids because 6 minus 1 makes 5, but 2 plus 3 also makes 5. I know, it's all down to the sign, but God, does 6 mess with kids. It is x minus 3 and x minus that, right? So, there's a hole. So, cross it out. Actually, I want to switch my color. So, there's going to be a hole at x is 2. What? How do I find the y value of that? Yes. I'm now going to graph this function. It's just there's going to be a hole at 2. It's going to be Thanos snapped out of the graph. So if I plug a 2 into what's left, it'll tell me where the hole is. So 2 plus 2 is 4. 2 minus 3 is negative 1. Negative 1 by 2 is negative 2. 4 over negative 2 is negative 2. So I'm going to go put a hole at 2, negative 2. Whoop. Then I've got an x-intercept at negative 2 dot. I've got vertical asymptotes at x equals 0 and x equals 3. Remember, it's always the zeros of those factors. Yes, ma'am?
Why is this? Oh, never mind.
Okay. Because remember that the thing we are graphing is now this. Okay. If I looked at the unfactored form of that, that's x plus 2 over x squared minus 3x. The only reason I'm writing that is because when I go to find my y-intercept, what happens when I function of 0 that? Oh, remember, we have special cases where we can start going through asymptotes. Now, right now, we have not yet crossed a vertical asymptote. To date, we have not done that, and you will not see that on test. It is possible. Just like in Algebra 2, maybe you didn't know that you could go through a horizontal asymptote. Guess what? You can. Okay, so just let you know, it is a thing. It isn't a thing we've dealt with yet. When I plug in 0, I get no. So make sure to actually tell me there's no y-intercept, so I know that you tried to find it, but you didn't forget it. Okay, no y-intercept. My horizontal asymptote is just y equals 0 because the degree of the numerator is smaller. So, it most certainly does, because remember that if I plug in y equals 0, if I replace y with 0 in the original function, there's a solution to that system. That means there's a little gap in the shield, there's a hole in the wall where the mouse can crawl through. The function can actually go through that asymptote. Yes, there is. No, because this becomes 0, this is 0, this is 0. I get 2 over 0.
But you can't divide it. I disagree. I think 2 divided by 0 should be 0.
I would like you to chop those, divide those 2 calculators among 0 people. No, it didn't go through the vertical asymptote that she was talking about. It's going through the horizontal one. No. So, seeing this, I don't know about you, but this doesn't seem like I've got enough information to actually graph it. I'm going to dump it in my calculator and check. Now, for my money, I would guess curl along up, loop above, question mark? That's generally the behavior they do. I could be completely wrong. This could be Samsonite. But I would go find a couple more points to be safe. Okay. Be careful on the right-hand side. Check your points when you go past x is 3. Be careful that those are all positive numbers. Know that you are above the axis. But on the left-hand side, prior to 0, see how it switches from negative itty-bitty number up to positive number. So that's how I know it was under the axis, slipped through the shield, and took off. It's like if you've ever tried to trap mice, this is that, you left that one tiny little spot where they can get through and they're gone. By the way, glue traps and all that kind of stuff, it's stupid. Put peanut butter on an old school wood trap, you'll get every one of them. They love peanut butter. Okay. Very first place I lived in, I had to kill about 24 of them. I had to kill the whole nest. It was an employee cabin at a state park. So, yeah, Fred lived in the wall. He was right next to my head. I had to thump on the wall and tell Fred to shut up at night. So, everyone got it? You got all your features? Okay. Shoop, shoop. And hit me, baby, one more time. Factor, factor, friggin' factor. Well, factors of -6 add up to -1. No! Yeah, you're right. Because 5 and, right? No. No, I just love the number 6 and how much it messes with kids.
Is it going to be 6 times 10?
Yes, you're right. +2, -3. Now, be careful. This one is going to have. Everyone becomes hesitant. Yes. Oh, it's another hole. Okay. So, shoop. Get rid of that one. Say there's a hole at 3, comma, plug a 3 in. -5/2. So at, right? Oh, that's a +3. Never mind. Yep. +5/2. 3 5/2. About here. And then x-intercept. -2. Dot. Vertical asymptote. X equals 1. Y-intercept. -2. Horizontal asymptote, or oblique, will come from the degrees. Degrees are the same, so I do what? Divide leading coefficients. There are no leading coefficients. We assume they're 1. So make sure you say that too. Y is 1 is my ha. And remember that when we have perpendicular asymptotes like this, they really love symmetry in those L shapes. So if that blue dot is left 3 down 1, then there's probably another one that goes right 3 up 1 from that intersection of asymptotes. These are the kind that we did back in Algebra 1 and 2. If this dot is left 1 down 3 from my intersection, then I can probably go right 1 up 3 to make another dot. Okay? Not always, but they do tend to have that behavior. Otherwise, jam it in your calculator, get some extra points. Okay? When you're done, it should look like this. Careful for the hole. Ew. Don't do the wiggle at the end. No wiggle. Wiggle, wiggle, wiggle. Anyone ever watch the Mickey's Mouse Funhouse? Oh, it is. Especially when you have to watch it over and over and over and over. Okay. Oh, hold on. I missed my negative. Fair is fair. Food.
Yes. I do like food also.
All right. Solve an inequality. You know, we did just talk about interest. Yeah, so like day 1 that they don't bring anything in, like you have to add sprinkles. Day 2, yeah. All right, where this says polynomial greater than 0, what kind of numbers are greater than 0?
Positive ones.
Cool, so I should find some zeros and then test in those intervals to see where I got positive values. I will tell you right now that I don't care how you find the zeros, so long as there's some work to back it up, these will be factorable. Number 4 will be factorable without split method, if you want to. All right. X to the 4th minus 23x squared minus 50 minus 2x to the 3rd plus 50x. Well, you got to find the zeros.
What happened with the question mark? It's not a question mark. It's a squared and then the negative. Oh. My bad.
And then
I was like, I'm also confused.
okay, if I look for my quadratic form in there, you can also just synthetic division, what you feel lucky about. That's cool too.
What? Yeah. I'm not saying
X squared minus 25 comes out, leaving a x squared minus 2x plus 2. This becomes x plus 5x minus 5. But last I checked, there are not factors of 2 that add up to negative 2. So I have to solve that however I might solve it. Don't assume that it's going to be imaginary, because what happens if they're compound numbers and your interval has to have compound numbers in it? We did see 2 examples like that. Yeah. So x squared minus 2x is negative 2. Half of negative 2 is negative 1. Negative 1 squared is 1. Getting x minus 1, the quantity squared is negative 1. X minus 1 is plus or minus I. X is 1 plus or minus I, which are imaginary zeros. So I will disregard them. Because, remember, the idea was to find out where my real zeros are and where this thing crosses the x-axis. So you could have either done the factoring business to find the zeros, or you could have done that synthetic division, 1, negative 2, negative 23, 50, negative 50, and say, I feel really lucky about negative 5, negative 5, negative 7, 35, what's that, 12? 12, negative 60, negative 10, 50, yay, it works. With 5, 1, 5, negative 2, negative 10, 2, 10, yay. Okay. So you could have either done synthetic division or factoring to find your real zeros. Once you find your real zeros, well, it's going to cross the axis at negative 5 and 5. I can test in those intervals now. I could jam it in my calculator and evaluate something less than negative 5, something between them, something greater than 5. I could also know the behavior of it. This is a positive x to the even. Those have end behavior of positive infinity and positive infinity. Each of my zeros happened once, so I know it'll go down through this 0 into negative town. It'll go up through this 0 into positive town. So you can know the behavior of the graph, you can test the intervals, or as long as you got that cute little number line on there, maybe you tested the intervals by just looking at your screen. Right? Can you see where it's above and below the axis? Good enough. Okay. But what I do want to see is 1. Do you got your cute little number line to show that you're actually testing this? 2, do you have either this or this to show how you got your zeros? And now you actually have to answer the question, where is this greater than 0? Looks like negative infinity to negative 5, parentheses or brackets? Parentheses both, because it's greater than, not greater than or equal to. Union, again, from 5 to infinity. Okay, so some sort of work to back up your zeros, something to show you did a test, your answer. No. Like, this is the solution set. It is the set of values where this inequality is true. Okay, so there's a polynomial inequality, then comes a rational inequality. Now I'm not just looking for zeros, what else do we got to find? Got to get common denominators to get the vertical asymptotes, to get the x-intercepts. So, hey, remember that x-intercepts are also solutions. I don't have to put everything on one side. I could just solve the equation as if it was normal equation. The solutions are my x-intercepts. These are my vertical asymptotes. Okay? Remember, solutions are x-intercepts, are zeros. The x-intercepts on a rational function are zeros of the numerator, right? But they're also just the solutions to the equation. You could just solve this like there was an equal sign in there, and the solutions you get are the x-intercepts because they're the same thing. Okay? We already know what our vertical asymptotes are going to be, right? 4 and negative 1. So you could just solve the equation to get the x-intercepts to go with it. So you got choices. Most of us, before I said that, would have just put everything on one side and combined it all into rational function. Okay. So, you. Step 1 would be this plus this minus this greater than 0. Right? You jam it all together and find out where the graph is greater than 0. In order to do that, I need to get common denominators. I'll tell you right now, I said it before, I'm going to turn this into plus a negative 1 on the numerator just because I screw up negatives. I don't want to have to remember that later. I'm just going to move it now. Then you're missing x plus 1. You're missing x minus 4. You're missing x minus 4. So grand total, the numerator now has a 2x plus 2 plus x squared minus 4x minus x plus 4 all over x plus 1, x minus 4. Now combine like terms. X squared, I see a 2x minus 5x is negative 3x. 2 plus 4 is 6. Over x squared minus 3x minus 4. Remember, I always put the uglier ones on the review because that numerator, my x-intercepts are not, it's not factorable, right? So my x-intercept's going to be nasty. That means my intervals are going to be nasty. I put the ugly ones on the review so that we get the practice with it. So we're going to have vertical asymptotes at, if these were my factors, x equals -1, x equals 4. From, wait. To find my x-intercepts, I need to solve. You're going to solve that however you want to solve. I can do quadratic formula. I can do complete square. Squared minus 3x is -6. Half that's 3 halves. 3 halves squared is 9/4. Add 9/4 to both sides. Getting x minus 3 halves. A quantity squared is, what's that, -24/4, 5, -15/4. And then Holly scratches her head and says, but it doesn't work. I'm going to end up with imaginary zeros again, aren't I? So where are the x-intercepts? There aren't any. That means I tried to find my x-intercepts in vertical asymptotes. It doesn't have any real x-intercepts. That means my cute little number line here only has the asymptotes on it. I have to find both. In this case, it didn't have any x-intercepts because the numerator didn't have any real zeros. Yes, ma'am? B over 2 squared. Half of 3 is 3 halves. 3 halves squared is 9/4. Or quadratic formula. Same difference. Like, y'all get what I'm saying, though, is I was seeing if maybe we had an x-intercept here and here to add to my number line. In this case, I didn't. You might. Sometimes you do, sometimes you don't. Rational graphs are weird. Test in the intervals. I can test in the intervals any number of ways. I could just jam a -2, a 0, and a 5 in there. I could dump the whole thing in my calculator. You have choices. I just care if it's positive or negative. If I plug a, what, -2 in there, I got 4, 4, 6, 6. So 10, 6, and 4. It's going to be positive. If I jam a 0 in there, I get a -3 halves. If I put a 5 in there, 25, 15, 10, 10s again. Another negative, right? No, that's positive. Okay. Or you'd look at your screen, same thing. And I get, where was this greater than 0? -infinity to -1, or 4 to infinity. Whew. Find x-intercepts and asymptotes, throw them both on the number line, test. Like, honestly, I would just write those as steps. Find your x-intercepts, which are solutions. Find my vertical asymptotes. Number line, test. 4, don't forget to actually write your answer. Because I have a lot of kids who get to the number line and then they quit. Yeah.
Come here. Please. We have a question.
Get over here.
How is this greater than 0? I don't understand how the negative.
No, it's positive. If I were to put in like a -5, or sorry, negative, what did I put in? -2. Plug -2 into the numerator. I'll get 4 plus 6 plus 6.
Okay.
Put a -2 into the denominator. I'll get 4 plus 6 minus 4. So I'll get 16 over 6. 16 over 6 is a positive number. Okay, you could just do the ask feature on your calculator. You could put parentheses in there. I just care whether it's positive or negative. The last one was analyze everything. Graph the thing. Tell me the transfer. Oh no, you don't analyze. This was transformations. Yay for you. Who is f of x's mathematical daddy? The parent function. Get it? The parent function. Who's the math daddy? Yeah. Who's the math daddy? What is the parent function? Remember that with exponential functions, you get a new parent function every time you change that base. So y equals 4 to the x is the parent function. That 4 is not some sort of stretch or compression. It's not a dilation of any kind. It's the base. And then I'm going to start messing with 4 to the x. 3 things happen. What are they? Big kid words. Vertical translation, up 2 units. What else? Yep. I can say a horizontal reflection, or I can say reflect in the y-axis. Now remember, you can say either vertical dilation or vertical stretch. If you're going to go to stretch and compression land, you better get it right. Okay, how do I know the difference between stretches and compressions? Greater than 1, less than 1. Like 5/3 versus 3/5. Okay, so that's a vertical stretch or dilation by 3. Now if I go to graph this, we're going to move up 2. I'm going to take powers of 4 and triple the value that I get. So normally anything to the 0 power is 1. I'm going to take it times 3. 4 to the first is 4. I'm going to take it times 3. They will go down to fraction town, yes, because yes, the creeper function. You can also plot by points on a calculator, but you need to be careful that you don't cross that asymptote. Your vertical translation, yes. So if I say 4 to the negative first, that's normally 1/4. If I take it times 3, it's 3/4. It's 3/16. It's 3/64. 3/256. 3/1024. It's just going to keep getting smaller. Oh wait, other way. It's got the reflection. Right values, wrong way. There we go. I'm on the fence about that. Because I said it and then I heard grumbling.
Yeah.
Hmm.
That is valid.
You get brownies too.
That's true.
So. Oh, we're done.
Yeah, but I can get brownies anytime. There's also my pride.
But you also love your kids, and you want to award.
Teenagers overuse the L word. If you would please, devices, hide them. Separate yourselves, mix yourselves around.
Love that.
So much.